Hey everyone, I am Miss Hu, your physics teacher. In this video, I will be discussing the answers to a past year question and then we will compare the answers to the mark scheme. For some questions, the answers will be covered first so that I can explain the thought process of getting to the answers, as you will need to know how to get the answers and not just what the answers are. Then, based on the mark scheme, I'll explain why the marks are awarded as such. Question 7. Figure 7.1 shows a sketch of the current voltage graph for an electrical component. 1. Name the electrical component. Explain how you identify the component from the graph in figure 7.1. So this is the graph, and you should be able to recognize the graph quite easily. This graph is quite obviously the current voltage graph for a diode. So that's the answer we're going to write here. Now, for the explanation though, you can't write, that's what I studied. You have to find something about the graph that explains why this is the diode graph. If you look at the graph closely, you can see that they've drawn a line here clearly on purpose so that you can see how the graph looks like. So in the negative region, there's absolutely no current. There's only current in the positive region. So this tells us that if the voltage is negative, that means that if the voltage is applied in the opposite direction, there's no current. Whereas there's only current in the positive region when the voltage is applied positively. So that's the explanation that we can use for our answer. So we can write here that there is only current flow in one direction. So let's check the answer. Yes, this is the diode. And the explanation they accept is when you say there is only a current in the diode when voltage is increased in one direction, or words to that effect, or you can just mention that there's only a current in one direction. So that's one more mark for the explanation, and that's how we can get 2 marks. So also just to show you a slide from my lesson on current voltage graphs, you are expected to know the current potential difference graphs for a resistor, a filament lamp, and a diode. So this is the diode graph, and the graph in the exam question looks exactly like this. So that's how we're able to immediately recognize that that is the graph for a diode. 2. Draw the circuit symbol for this component. So obviously you need to know what a symbol looks like for a diode. So basically the diode looks like a triangle, and you can think of the triangle as representing the direction of the current. And we have a line in front of the triangle to indicate that's the direction of the current flow. So if you check the mark scheme, that's the symbol. Now, some of you might come across diode symbols that look a little bit different. You may have seen diode symbols where the line doesn't go through the triangle. This is actually also the correct symbol for a diode. So the reason why we have a line through the diode symbol is because that's what the symbol looks like in the syllabus guide. So this is the syllabus guide, and this is the symbol for the diode. However, to my knowledge, if you draw this symbol, it will still be accepted because this is also the universal symbol that is accepted for a diode. Drawing the correct symbol will of course give you 1 mark. B. Figure 7.2 shows an electric circuit for 2 identical electric heaters, A and B, connected to a mains supply of 230 volts. So this is the circuit with the heaters in parallel and switches and emitters connected in the circuit. S1 is closed and S2 is open. The reading on the emitter is 3.9 ampere. 1. Calculate the resistance of heater A. So this means a complete circuit only involves heater A and the emitter. In that situation, the potential difference is 230 volts and the current is the reading on the emitter, which is 3.9 ampere. So to calculate the resistance, we just use the formula of V equals IR. So let's substitute V as 230 volts. Current is 3.9 ampere, while the resistance is unknown. When you calculate it, you would get 58.97 ohm, but you don't have to write so many digits because remember that in Cambridge IGCSE, they prefer you to write the answers in 2 significant figures. So we can just write this to 59 ohm. So this particular tool doesn't allow me to type in or copy and paste the ohm symbol, so I'm going to write this out with the pencil. So ohm. And that's the answer we can write in the space over here, 59 ohm. So now let's check the mark scheme. When we got the correct answer with unit, that's 59 ohm, you get 2 marks. But remember, we always want to write the working out in case your calculation is incorrect. And this can happen. Sometimes you get the correct numbers, but you key them into the calculator wrongly, and then you get the wrong answer without realizing it. So what if you didn't get the correct final answer? Can you still get a mark? Yes, you can if you wrote the correct equation or you had the correct substitution. So either one, whether the correct equation or the correct substitution, will give you 1 mark. 2. Calculate the energy transferred by heater A in 5 minutes. So which equation can we use? The only values they have given us is the potential difference, the current, and now you've calculated the resistance. They've also given you time. So the best equation in this case is to use the electrical energy formula, which is E equals IVT. So all we need to do is substitute the values in: 3.9 ampere for the current, 230 volts for the potential difference, or V, and time 5 minutes. But remember that you must write the time in seconds. So I'm going to write here 5.0 times 60 because that's how you convert minutes to seconds. When you calculate this out, you're going to get 269,100 joules. But remember that for IGCSE, we prefer to write to 2 significant figures only. So I'm going to round this out to 270,000 joules. That's the answer we can write in the space provided over here. Let's check the mark scheme. So yes, the answer is 270,000 joules, or you can write it in standard form. In fact, actually standard form is preferred. Getting the correct answer of the unit would give us 3 marks. But as I mentioned earlier, always write the working out just in case your calculation is incorrect. So what if you didn't get the correct final answer? You would get 1 mark for the correct equation and for converting minutes to seconds. So these are the marks you can be awarded if you didn't get the correct final answer with unit. 3. S1 remains closed and S2 is closed. Determine the reading on the ammeter. Show your working. So for this question, this time we're closing both switches S1 and S2. That means that both the heaters of A and B will be functioning, and the circuit now functions as a parallel circuit. There are 2 ways to solve this question, and I'll go through both methods. First of all, we already know that the current that's flowing through heater A is 3.9 ampere. So even if you add another heater in parallel, the current flowing through the heater will still be 3.9 ampere. Why? Because in the first place, when S2 is open, we have a complete circuit, and the question already told us the ammeter reading is 3.9 ampere. Even if you add another component in parallel, that doesn't change the potential difference across A, meaning that the current reading will still be the same. So even if we switch on S2, the current flowing through A will still be 3.9 ampere. They told us that the electrical heaters A and B are identical, which means that they have the same resistance. So because this is a parallel circuit, both heaters will have the same potential difference. So with the same PD and same resistance, the current flowing through both A and B each will be the same at 3.9 ampere. So therefore, to calculate the ammeter reading, you just need to take 3.9 plus 3.9. And that's the first method to solve this question. So we'll write here, ammeter reading is 3.9 plus 3.9, giving us 7.8 ampere. Now, what if you didn't identify that the current would be the same in both heaters? So here's another method you can try using your knowledge of parallel circuits. Because the heaters are in parallel, you can first calculate the total effective resistance and then use the value of the potential difference to calculate the ammeter reading. We have already calculated the resistance of heater A, and the question has already told us that the electrical heaters A and B are identical, which means that if A is 59 ohm, B is also 59 ohm. So we can first calculate the total effective resistance by taking 1 over R equals to 1 over 59 plus 1 over 59. Calculating this, we would get 2 over 59. And from this, we will be able to work out that the value of R is 29.5 ohm. From here, we can use the equation of V equals IR to calculate the value of the ammeter reading. So 230 equals to I times 29.5. And when you work it out, you will get the same value of the current, which is 7.8 ampere. By the way, for the total effective resistance, I use the 1 over R equation. Some of you may not be familiar with this. If you try using the calculation of R1 times R2 over R1 plus R2, this also works. So you can take 59 times 59 divided by 59 plus 59, which would give you the exact same value of 29.5 ohm. Whichever the case, as long as you use the correct equation, you will be able to get the correct answer. So anyway, in either method that we've used to determine the ammeter reading, we got the same answer, and I'm going to write the value here, which is 7.8 ampere. Now let's check the mark scheme. So you can see that the answer is 7.8 ampere, and this would give us 1 mark for the answer with unit. The other mark is awarded from any one of the following: by identifying that the identical heaters have the same current, which is 3.9 ampere in each branch, or by adding both currents together, or by calculating the resistance, which is 1 over R equals 1 over R1 plus 1 over R2 in any form. And this equation is also accepted because it's actually derived from the equation that is originally in this form. And that's how you solve question 7. If you found this video to be helpful, click like and subscribe. And do let me know how you have found this video to have helped you. To watch videos on other questions, check out the playlist on my YouTube channel or on my website, physicsrocks.com, to find the question that you are looking for. If you have any requests for a particular question, drop your request in the comments below, stating the year, month, variant, and question number. And if I haven't covered that question yet, I will do my best to come up with the explanation video as soon as possible. All the best for your examinations!